Okay. So on the denominator, after I found the common denominator, so we're going to add together x plus 2x plus 4. Is it okay if I distribute as I'm adding? Does anybody mind that I'm going to distribute and add at the same time? So I'm really having x plus 2x plus 8?
Yeah. 3x plus 8.
Will be. I'll do that next. So I combined my common denominators on the bottom. I added my numerators. I now have 1 fraction over 1 fraction. That's what I wanted to do. So we used what we did yesterday to add like denominators. Now we're going to use what we did last week where we are dividing. We're dividing. So instead of dividing, multiply by the reciprocal. So instead of taking 5 over x plus 4 divided by x plus 2x plus 8 over x times x plus 4, we're going to flip the bottom one. So 5 over x plus 4 multiplied by x times x plus 4 over, and then I'll just combine my like terms while I'm doing this, 3x plus 8. I can, but I don't want to. Because our next step, when we multiply, we want to have things factored and see if anything cancels, and that's already factored. So less steps for me to do in the future. The time you would want to distribute is if you were adding, like we did up here. We distributed because we were adding them, but when we are multiplying, we want them factored. Okay. When I multiply, now we've done this before too. We did this last week. When you multiply straight across, but if something is in the denominator like x plus 4, there are understood parentheses there. There are understood parentheses with the 3x plus 8. There's understood parentheses. So we multiply straight across, and then after you multiply, look, I multiplied. After you multiply, is there anything that we can cancel out? X plus 4, and that's what x?
So it's 5x over 3x plus 8.
One moment, I'll get there. So the question is, can I cancel these x's?
Yeah. No.
Okay, on top, I can factor 5x, 5 times x. Look, I factored it, 5 times x. On the bottom, it is not just 3 times x, it's 3 times x plus 8. So this is like one binomial on the bottom. How do you factor binomials? GCF, or like difference of squares, stuff like that. Is there a GCF? I cannot factor this, therefore I cannot cancel x. Otherwise, something cute will. Hedgehog in this class, I guess. Okay, now, so we've done everything, almost everything that we've done in this entire chapter in one question. Almost everything. We first added, we found common denominators, then we added, then we changed division to multiplication, then we multiplied, then we simplified with canceling. When we did all that before, sometimes there was like x cannot equal. We had to do that too. So go back to the beginning. What could x not equal to at the very beginning? If you look at the denominators, what could x not equal to at the beginning?
-4 and 0.
Okay. -4 and 0. What can x not equal to now?
-4.
No.
Oh, that one?
Mm-hmm.
8 over -3.
different from the original question? Is this a different exclusion? Are they different? Yeah. So if they're different, you have to include what is different. So we don't have to include the one that's here. We have to include the ones from the original. So this, we don't have to include. This is just me showing you that the exclusions are different. So the exclusions that go in our answer are the ones from the beginning that are not the same as the end ones. X cannot equal 0 and X cannot equal, what was it? Negative. So when you're saying that these two expressions are equivalent, they're not equivalent at those spots. Okay, so we're going to do a few of these examples and have you try some on your own. Let's do another one. Okay, so we want to try to get one fraction over one fraction. Do we currently have that? No, we have one fraction over 2. So on the bottom, we need to add together those two fractions. So we have one fraction over one fraction. I need common denominators. What should I multiply 3 over x by? X minus 2 over x minus 2. What should I multiply x minus 2 by? X over x. Remember, there are understood parentheses. Wherever there's a denominator or a numerator, there's understood parentheses. So now I have 6 over x minus 2 over x over x parenthesis x minus 2 plus 3x minus 6 over x parenthesis x minus 2. So I kind of distributed that 3 as I was going, if that's okay. From here, we need to add the stuff in the denominator. My numerator is still the same. But in the denominator now, I have 4x minus 6 over x parenthesis x minus 2. If you have questions as we're doing this, you should kind of like stop and say, hold on, where'd you get that from? You lost me for a second. Like, ask as we go. Don't wait till the 5th example to say, I never understood this back then. Sure, ask it as you go. Once you've added the bottoms together, we now have a fraction over a fraction. That's what we want to do. So instead of dividing by a fraction, what are we going to do? So I keep 6 over x minus 2, but I'm going to multiply by the reciprocal. X parenthesis x minus 2 over 4x minus 6. We are multiplying. How do we multiply?
Straight across.
Straight across. Does anything cancel?
Yeah.
X minus 2. So it's 6x over 4x minus 6.
Can't you take the GCF of where?
Yeah.
Totally. 100%.
And
Doing
then
it.
wouldn't we do the same thing for 6, 13, 15?
So at this point, first of all, why can't I cancel out? Why can't I cancel out those 6s?
You're not supposed to. You know,
Because
which
just
I
can't.
know why.
One's
Why?
multiplication, one's subtraction.
You have a question? Why can't I?
Or is it because the top one's a monomial and the bottom one's a binary?
Because the bottom one is a binomial, in order to cancel a 6, I have to factor it out. And it doesn't factor out. I can't factor the x's. The factor of the x is on top because that's just 6 times x. But on the bottom, I can't take out the x, so I can't cancel the x either. It's because it's a binomial. Now, Alex, what we're going to ask? Of course,
I figured it out.
Okay.
When I multiplied the 6 and the x times x minus 2, I didn't put the x over there, so I had 6 over 4x minus 6. I was wondering where you got an x from.
Now you see it. Okay. So what we're gonna do now is what Brandon said. He said, that denominator factors. That 4x minus 6, that factors. There is a GCF. What is the GCF?
2.
Don't forget the top.
I'll just do the bottom first. That's better. 2 parentheses 2x minus 3. And since a 2 factors out of the bottom, is it possible that a 2 could factor out of 6x?
Yeah, 2 times 3 times x.
So since the 2 can factor out of the top and the bottom, we can cancel it.
Whoa.
Right.
You were right.
See, I don't
So
think it's
3x over 2x
You did
minus
some of it.
3. And then
Yeah,
you gotta
he said I
find
was.
the
I'm having
exclusion.
trouble. I'm not having trouble.
We'll see.
Yeah, no
That's
problem
what I
on
heard.
here.
So what do we do now?
You do the exclusions.
Cross out my 3's,
No,
No,
cross out my x's.
no.
no,
You're a silly goose.
So look for the exclusions. Let's go back up to the original. What exclusions were in the original? X cannot equal
2.
2, x
0.
cannot equal 0. But what about the final answer? Is 2 or 0 an exclusion here?
I don't think so. 12.
So if they're not exclusions in the final answer, then it's a change and we need to include that.
can't understand it.
What'd you say?
You can't understand it. You can't look at the 2 functions and
Right.
understand it.
All right. Do we have 1 fraction over 1 fraction? Then make it 1 fraction over 1 fraction.
I forgot how to do it. Oh, I know what to do.
Fractional.
By the way, this is actually easier to look.
This one. What is our goal? We need to get what over what?
The same denominator over the
No.
same.
Like, our
Fraction over
ultimate goal is we need to get
Oh,
to
1 fraction.
1 fraction over 1 fraction. Currently, we have 2 fractions over 2 fractions. We need 1 fraction over 1 fraction. Or did you not go past this?
Here's my license, it's okay. I know.
Okay, so on the top, I need 1 fraction. Currently, I have 2. So I have to multiply the second fraction by 2 over 2. So that on the top, I have x over 6 minus 2x over 6. That's my top. So on the top, I have, can I subtract x minus 2x? Can I subtract those, x and 2x? Are those like terms or not like terms? X minus 2x. So what do I get if I have 1x and I take away 2 x's? Negative x over 6. So that's my top all the way across. The bottom. I need common denominators of 10. So I'm going to multiply this one by 2 over 2.
Already?
I'll get 2x over 10 minus 7 over 10. 2x minus 7. Is 2x minus 7 like terms?
No.
They're not like terms. You cannot subtract 2x minus 7, so I leave it as 2x minus 7 over 10.
Reciprocal.
So once you get to that spot, we have 1 fraction over 1 fraction. So you're going to take your top fraction divide by the bottom one by multiplying by its reciprocal. Gosh.
How many emails are you getting?
No, it's not.
Copy.
That's not something that normally happens. Okay,
Yeah,
Multiply it
not
together?
that cool.
multiply it together, straight across. And then is that my final answer?
No. Actually, no. It's 2.
It's actually not.
You take out a 2.
So we can factor a 2 out of that negative 10x. We can factor a 2 out.
Yeah. Let's see what it is.
We'll have negative
5x.
5 times 2 times x over 2 times 3, 2x minus 7. So that we can cancel out the 2's. There is no need to distribute that 3 back in. There's no need to do it. You can just stop there. That would be extra work. No. I'm giving you extra credit if you do something you don't need to do.
But
It doesn't help you at all. It's just like busy work.
If I do it on a test, it's incorrect.
If you do it on a test, I'm going to get annoyed. Because I told you not to do it.
Suggested not to do it.
I suggested not to do it, heavily suggested. Don't do it. All right.
But what if I want to?
So you do it minus 10 points. Okay.
Wait,
Just
what
for
if we
me?
solve for X?
Exclusion.
Discriminate.
But we can't solve for x. There's no equal sign.
You
I
wrote
put it in. It doesn't equal, it equals the original, but it doesn't equal the original. Or is there any exclusions that makes it different? It equals the original. You can't solve for x. There's no exclusions in the original.
What if you said that equal to the original? What would happen then?
Then they should be equal unless there's exclusions. They should be equal to each other. But you won't be able to find out what x equals. You just know that they're exactly the same. You'd get something like x equals x.
Are there any exclusions?
There's no. Because there's no x's.
in the
Well,
denominator?
actually there is an exclusion, but I'm not going to work through this one. It's really messy. It is really messy. There is an x in the denominator of the whole thing. You'd have to solve that one for 0.
Don't do it.
But it is the exact answer as this one is, so it's not a change. So there is an exclusion, but it's a really messy one. Just so you know, it's the exact same as this one, so it's not a change. Okay. All right. Take a moment. How are we going to start this one? We need to get one fraction in over one fraction. Currently, do we have one fraction over one fraction?
Yes, we do.
No.
As of now.
Actually, we don't have one fraction. There's other stuff with you.
Oh, 4 over 1 is a fraction, my dear. Right?
Technically.
It is.
Oh,
Okay.
we could have just left it as though those aren't fractions. We can't do anything and been done with it.
No, we could not do that. So on top, we should have 2 over x minus 4x over x. And on the bottom, we should have 2 over x plus 3x over x. Can I cancel the 2 over x's? Can I just cancel them out?
Yeah.
No.
No.
Yes.
What?
That's fine.
Hedgehog.
Why?
Have you seen a hedgehog?
Yes, I have.
Then you would not be saying that.
I have, I promise you.
Or that.
You want to kill a hedgehog, Brandon?
These are binomials. You cannot cancel part of the binomial. Okay. Then we're going to subtract on top. Is 2 minus 4x like terms or not like terms? 2 minus 4x.
No.
Not like terms. How about 2 plus 3x? Like terms or not like terms?
Not like terms.
So we can't actually add them. You just put them next to each other with addition or subtraction signs. Now we have a fraction. Over a fraction, we are at the division stage. Multiply by the reciprocal.
The x is canceled, so then it's just 2 minus 4x over 3x plus 2.
So these will cancel. We have 2 minus 4x over 2 plus 3x. Can I cancel the 2's? No, you cannot, because this is a binomial. Is it factored? This is a binomial. Is it factored? Can the top be factored? Let's factor it. Can the bottom be factored? So if it can't be factored, I'm not going to cancel anything. If it can't be factored, I'm not canceling. You can only cancel if you factor something out.
Don't waste your time.
That's not wasting time. That's doing things mathematically illegal. Do we have any restrictions, any exclusions in the original? Do we have any exclusions in the original?
0. Yeah, 0.
0. Is that an exclusion for this one?
Yeah. No.
So we have to include it.
Maybe.
It's not. X would be by itself in the denominator if it was an exclusion for 0. All right, next one. Do we have 1 fraction over 1 fraction? Yet. We have to find the common denominator
Short.
in the bottom. What do I need to multiply the 2 over x minus 3 by? X plus 5 over x plus 5. What do I need to multiply the 1 over x plus 5 by? X minus 3 over x minus 3. They don't have anything in common, so I can multiply by the other one. On top, nothing changed. On the bottom, we now have 2x plus 10 over x plus 5 times x minus 3 plus x minus 3 over x plus 5 times x minus 3. Should I cancel these x minus 3's?
No.
You're not even looking at what I'm talking about. Should I cancel them? Should I do it?
Don't do it.
Don't do it. Don't do it.
Don't do it.
I just put it in. Don't cancel them out. I just put them in. Don't cancel them out. Some of you will do that. Some of you will do that. Where you just put the x plus 5 in, and then you're going to go, oh, I can cancel out x plus 5. Like you just put it in there on purpose. What do I need to do at this point? I don't want to cancel yet. What do I need to do? I need to add. That's what I'm doing here, is I'm adding, so I have to.
Cancel the x plus 3. Or
Why?
minus 3.
Say that again?
Why wouldn't we cancel the x minus 3?
X plus 5.
Because I wouldn't be able to add that. If I cancel it out, I don't have like denominators anymore. So we need to add it together while we have like denominators. While we have like denominators, we need to add it together. So I'm going to add these together. 3x plus 7 over x plus 5 times x minus 3. Everybody know where I got 3x plus 7 from? What did I do?
Oh, you would put both.
Kenzie, do you know how I have 3x plus 7? Can you tell me? Tell everybody.
You added the 2x and the x and the x to the circle.
Right. I just added this stuff and combined my like terms in one step. Okay, so now I have a fraction, one fraction over one fraction. So instead of dividing, what should we do? So I'm going to have 3 over x plus 5 multiplied by x plus 5 times x minus 3 over 3x plus 7. Remember, these are all factors. They're all in parentheses. They're all binomials. So we're going to multiply straight across. Anything cancel? Anything else to cancel? Can I cancel those 3's?
No.
Yes.
Don't you dare.
Why not?
Why not? Why can't I cancel this? Well, I don't know which 3's you're talking about. Why can't I? But the answer is no.
Any three.
Because the denominator has to be factored out.
Because the denominator is not factored. And it is a binomial. This is a binomial. You can't cancel part of the binomial. Are there any exclusions at the beginning that are not at the end? Are those exclusions here? Nope. Yes. Where are you? Where are you? When I'm here?
Yeah, so when the 3 and the 3 would go 3 with the x plus 5 and our 3 with
When you are multiplying, I just made numbers. If I'm multiplying 3 times 2 times 5, do I do 3 times 2 and 3 times 5? No. You just multiply 2 at a time and multiply that answer by the third. So I'm multiplying these two and then taking that answer times 3. Okay. You would only distribute if there was a plus sign between the two things, or a minus. Okay. You try this last one.
Wait,
Show me
isn't-
the answer. Yes.
On the last one,
Yeah.
isn't 3 in the equation at the end though? Because I thought it was, no, that's on the top end.
Not in the bottom. I'll leave this work up just in case you need to
Okay.
copy any of it down still. Try the last one. I'm gonna walk around, check it off. What's that comment?
Oh, dang it.
They see yellow highlighters. Once I check you off, your assignment is on Big Ideas. So once I check you off, you can start on your assignment. I'll stop recording this.